low, and it's not really helpful when you are combining two images and trying to get a resulting image which can only be obtained through logical operations. And after doing logical operations, we'll go ahead and look at color thresholding, color segmentation, or color thresholding. We'll be looking at MATLAB's color thresholder app, based on which we can use different types of um, color spaces such as RGB, HSV, and LAB color spaces to segment a specific color, such as uh, such as this orange, as I've shown just now. And then we'll also see how to convert from RGB to HSV, HSV to LAB, um, and um, we'll get the profile of the color profile of the image through a straight line to get the values of different um, colors based on which we can do the color segmentation. Apart from that, we'll also see how to deal with those images where you have lots of different colors and you just want to specifically differentiate a single color with great accuracy using RGB, HSV, and LAB color spaces. Finally, you will get to know which one is more suitable for all the color segmentation tasks. And then we'll look at edge detection. Under edge detection, we'll try to learn different algorithms that are used for edge detection, such as Sobel, Canny, Pruitt, Log, and some of the other methods. As you can see, Sobel just shows the outline of the outline edge detection, just as the outline edge detection of the specific shape, but Canny does the detailed edge detection of the shape. Likewise, sometimes it's not just enough to apply a specific algorithm. Even though you're applying correct, even though you're applying a correct algorithm, but still you will not get the required edge detection. You might not be able to remove the noise for using that method, um, or your edges are not strong enough to see. So in such cases, we get the edge value based on which you are doing the detection, and you'll increase or decrease it. We'll get to learn how to do that as well in this course. That's really interesting. After doing edge detection methods, after doing edge detection, we'll move forward and we'll see linear and nonlinear filters. We'll see linear and nonlinear filters. Under linear filters, we'll see Gaussian filter, um, average filter, and some of the other filters. Under nonlinear filters, we'll see entropy filter, range filter, and standard deviation filter, and also Laplacian, which is a nonlinear filter. All right, we will be using these filters to sometimes to blur the image, and sometimes we'll sharpen the edges of the image of the shapes. So it depends what you want to achieve, and based on that, you'll select a specific filter. Before learning about filters, we'll look at convolution um, in detail. All right, and then yeah, as discussed under nonlinear filters, we'll be learning in detail about entropy and range filters. And right after that, we'll look at histogram processing and um, log gamma transformations. Histogram processing is really um, useful, and it's a very powerful tool to do the contrast enhancement and um, intensity distribution. So we'll do linear stretching of the histogram. We'll do histogram equalization and adaptive histogram equalization. And then we'll look at log and gamma transformation. These are really useful if you're specifically dealing with X-ray images, and also sometimes it also works on specifically this, especially this gamma transformation really works well on any type of images. And after after learning about histogram processing and log gamma transformation, we'll also see, as we have discussed already, edge detection, and we'll see, as we have discussed, we'll look at edge detection and object detection as well. As I have already discussed, we'll use different kinds of methods, different kinds of algorithms, and logical as well as arithmetic operations to get the required result. Sometimes if we are doing edge detection, we need a different algorithm, and if we are doing object detection, we use a different method altogether. So we'll deep dive into those topics. Apart from that, we'll also do basics. We'll also learn basics of convolution, and we'll also do texture segmentation using nonlinear filters. Um, as I've already said, that we'll be using entropy, range, and standard deviation filters. Those ones we'll be using for texture segmentation. Basically, basically we are applying nonlinear filters. Um, basically we are applying nonlinear filters to do the texture segmentation. Right. So we're also learning about the filters and also getting to know how to apply them. Right after that, we'll also learn about morphological operations such as um, dilation, erosion, opening, and closing. These are really powerful and really exciting to learn, and it's a fun to apply these on the images. We'll also learn how to remove noise by using um, lots of linear filters as well as nonlinear filters. And then we'll also use morphological operations to remove the noise. And the next thing we'll be looking at is finding region properties and analysis. By learning this one, you'll be able to find out area, perimeter, centroid, bounding box, and lots of other properties of the connected components within the image. This will take you to the next level, and I hope be uh, you'll you'll be really enjoying these topics. So are you ready to take your skills to the next level? I hope you do, right? So enroll now to get started. Thank you.